remember?
It's okay. I don't mind. It's all the same.
Yeah, I seen you on a video.
You did on the YouTube
Yeah.
one? Darn it. I had no idea. Yeah, so I don't really. We're not supposed to be filmed and put on social media.
Oh,
and
sorry
I guess
about
that kid got away with it because my name's not mentioned
Yeah.
in there, so it's not my preference. But I watched it. I didn't screw up too bad, so it was okay. Yep, I can talk about all this stuff that's in here.
Yeah.
I'll just kind of wait and see if another
That's the
anyone else wants to filter. You can ask me anything, and then if not, I'll just kind of show you some of the stuff we got going on.
Can you tell me about the when you disrupt the signal from the South Pacific buoy from the facility in
Okay.
Colorado coming to Wasilla and Ely.
Okay. So most of those questions you're going to want to get answered during the lectures with Dr. Fallon and Dr. McCoy. You know, they're mainly there to talk about the science. I'm out here to give representation of the transmitters and the engineering that's involved with what we do out here. So the science stuff, I'm just going to direct you over there just so it doesn't kind of distract from what we're doing out here. This is mainly a tour of, so you can see how we do it out here. 180 of these antennas, 180 transmitters, 30 of these shelters house 6 transmitters each, and so that's what this portion of the tour is about. So all these shelters are the same, 30 of them, got 6 transmitters each. This is what we call a transmitter, but the transmitter is really 2 separate power amplifiers. This is a power amplifier that will operate the east-west antenna, and this one will operate the north-south antenna. So they can be operated they are operated independently, but with a common computer and circuit breakers and power supplies, things like that. So one side of the transmitter, this power amplifier feeds a portion of the antenna. As you look outside, when you see the antennas, the easiest thing to see is the big booms on the top, and they're cross dipoles like this. So one of these big cables right here on the output is feeding this one, and the other side is feeding that one. And by doing it that way, we can control the phase angles of how those signals are generated. So this transmitter will send a slightly different phase to an antenna than that one, than that one, than that one, and every one of them has a slightly different phase to it, and all then 180 of them work together to send that radio wave up and straight up. So like a normal radio station that you tune into your car can use like a cross dipole again, and if you phase it just right, all the energy can go in every direction, equal energy in every direction. So you can drive this way and hear the radio station, you can drive that way. But by changing the phase, you can change how that radiation pattern is sent out. And by doing every one a little different, that energy is coupled together, boom, and it goes up. It also comes down, and that's what the ground screen outside is for, is to reflect that energy that's coming down back up to help reinforce the wave. So all the energy is going up to where we want it to go. And these are the transmitters that do that. All these transmitters talk to each other, so to speak, but they do that through the control room back in the main building. So all the information from these transmitters, controlling them and the feedback signals from them is all fed back to the main building via fiber optics, and then that the control room has a status of what's going on out here.
So do people
Yep, go ahead.
So people aren't sitting here monitoring, these are just, you come in here
We
to
do-
do things, but otherwise the
That's,
monitoring.
that's
goes up there.
correct. So, maintenance is done out here, we operate individual transmitters to do maintenance, calibration, stuff like that. But once everything is operational and we put it in its remote state, we don't have to be out here. We do come out here from time to time during operations, and that's just if we have a circuit breaker trip or we've gotta replace a component. We can do a few things when we're operating, mainly on the front side of this transmitter, and not anything on the back side of it, because the energy is still coming from other towers back into these cables. But in general, we don't have to come out here, it's all done remote control.
I bet that would be a wicked RF run.
Yeah. Yep, and there's lots of safeguards on these transmitters to prevent that from happening, and there's really only 2 qualified people that even work on transmitters, so
Oh, wow.
it's not really an issue. no one's coming out here but two qualified people, me and the lady that's next door.
So I read about the huge power requirement.
Mhm.
How often do you do that?
To transmit and do the science with it. So back in the day when the government ran the facility, we could operate for 2 to 3 weeks, and we would do that maybe 10 to 14 hours a day. So that was back in the early days when the site was new and the science was new and stuff like that. But as the funding decreased for the project, those science campaigns got shorter and shorter and shorter. But then the government shut the facility down, and then this whole place sat in mothballs for about 3 years until we started resurrecting and going through the transmitters and making them operational again. Now that UAF, correct. Now that UAF runs the project, we're slowly ramping up to that. So like we've run 4 science campaigns here, and they've been 5 days, 8 hours a day, something like that. So it's been a slow start. Our first science campaign, we only had 60% of these transmitters and shelters operational. So that was just kind of like a test. Yes, our control systems work. Yes, we can bring the transmitters in operation. We can do what we did before. And then we had a break, and we brought 20% more transmitters and shelters online. We ran 2 more campaigns doing that. So those campaigns have been a week long, 5 to 8 hours a day. And that's just, getting the ball rolling again. But we could, depending on staffing and depending on the science, we can operate as much as somebody wants to fund it.
Right. And is it fully operational then?
Right now, 80% of this is available. So, 80% of the transmitters have been resurrected, have the vacuum tubes put back in them, fully tested, calibrated, and ready to go. The remaining 20% is when we're gonna have time to fix them and the resources and the money and stuff to do that. So it is fully functional, other than the fact that 20% of them haven't been gone through and qualified just yet.
You
So
said as long as somebody's funding it, so you are renting the facility to independent research?
Well, UAF owns the facility, and they charge $5,000 an hour for research.
Wow.
So if somebody wants to,
So anybody can come
It's
and
good to know.
anybody can do that. And we had a crowdfunding experiment we did a couple campaigns ago where a guy collected $2,500 and got half hour or something like that.
Oh, cool.
So and I believe he played Jimi Hendrix. If you want to use HAARP to broadcast, you can pay the university and you can use it during our operational campaigns. Correct.
How much does each antenna push out
Well,
as opposed to like a radio station?
yeah. So all right, this is a 10 kilowatt power amplifier. This side puts out 10 kilowatts. That side puts out 10 kilowatts. So 20 kilowatts times 180, 3.6 million watts of radiated power is available. Right now we only have 80% of that. Megawatts?
Megawatts?
Yeah, that's power.
Okay.
And as far as megahertz, we're 2.8 to 10 megahertz. That's our range of frequencies that this transmitter can broadcast. Yeah. So that's how the university, that's their business model. Back when the military ran this site, researchers could get grants or permission to run it. The military operated this for the 2 weeks for them.
they've got blocks of time during that to do their experiment. But now researchers have to pay the university to operate it, and those costs, that $5,000 an hour, doesn't even scratch the surface of what it costs to maintain and operate this site. That pays for fuel, staff, resources, and what it costs us to put this whole thing back together. Doesn't even scratch the surface. But you have to start someplace and get that interest back and let the scientific community know that HAARP is operational again, and we can do research here.
How long has UAF had this?
2015?
2015, right, September, October of 2015. It took them about 9 months to kind of get their arms around what it is they had here. And starting the summer of 2016 is when we started resurrecting these shelters and transmitters and bringing stuff slowly back online. And that's how long I've been back out here. I was part of the original crew that built this site. I work for another company out of Anchorage, but I'm contracted through with UAF to help them make this work.
What company is that?
Kaktovik,
How much?
used to be Marsh Creek,
How much total megawatts are you pumping out with all 180 of them?
3.6
3.6. Okay, so that.
3.6 million watts.
How much radiation is coming down? Can you talk about this field to protect it to shoot it back up?
Yeah, well, okay, so how much is coming down? So 3.6 million watts.
Of radiation?
Yeah, so half of that is going up, half of it is coming down, but the half that's coming down is reflected back up. So, there's only from the antenna to this ground screen is where that field is, but it's just reflected back up as if it's all part of the antenna anyhow. So you could kind of say none is coming down.
How much amplitude are we pushing out of this? For the phase, the amplitude in the phase? For the
Well,
the
so you-
VLF?
Well, but you're still talking about
Power.
at 3.6 million watts, right? So amplitude, you would be talking about the magnitude of a voltage. So these vacuum tubes have 5,200 volts on their output, but that's just the